So this is the hands-on lab for the optics unit, and it's about the pinhole magnifier. And so our objective here is to show the effects of a pinhole device and illustrate how your eye focuses on different objects at different distances. So what we started with was just a regular index card, and then I cut a hole through it, and then attached a piece of aluminum foil, and then with a little stick pin, just poke a hole straight through there to have a small pinhole, and then from there I can use it to hold it near my eye and look at different objects that have dim lights, such as the light coming from a cell phone. So if I use that and use the light coming from my cell phone and look at it starting about 3 feet away or so, or a little bit less than that, but then slowly move in closer and closer and closer, I can see that the image appears much larger when I'm up close because I'm focusing on a smaller area. And so then I can do the same thing with a larger hole through my piece of foil by poking it with the tip of a pen. Okay, so that's a much larger hole now. And I can do the same thing looking at the light of my phone. And pretty much the same thing occurs. The image looks bigger as it gets closer because I'm focusing in on the specific part I was looking at, and also because the image is much clearer since I have a wider hole to let light come through. So and now I'll be doing the same thing with my fingers, and if I just hold them like this is an even bigger hole than the one poked by the pen. And so I can do the same thing with my phone light and just set it here, and as I get closer and closer, it definitely magnifies, but I can already basically see the whole thing through my fingers because the hole is so much larger, and so that makes it a much clearer image as well. We saw that we were able to see how the eye works in a lot of ways. We have a diagram, and in this first one you see a focused image where the light rays are focused on the focal point of the eye, which is right in the back there. And then in the second image, we have a more blurry image where the light waves are reflected and focused beyond the eye so that you can't really see them that well. And then this final one is a much clearer image, the one that you see through the pinhole. It's still a little bit blurry, but you are focusing on a smaller area, so it's not quite as blurry as the other blurry image. And so that's basically how your eye works. You have a focal point at the back of your eye, and the light waves should ideally be reflected onto that point so that you can see the image. When that's not the case, you get people that are nearsighted or farsighted. And so nearsighted people will usually see things as being blurry at a distance because the image is focused in front of the focal point in their eye. And then with this, like a pinhole device, if they're using it to try and magnify things, they would be able to see things a little bit more clearly because they would be focusing the light rays differently than if they were just looking around like normally. And then when you have people that are farsighted, the light rays are focused usually past the focus, like we saw in the diagram of the eye, and they normally see things as being blurry up close, and with a pinhole magnifier or something to that effect, they would be able to see things more clearly. And so we also saw that the distance, when I started out at a farther distance, it wasn't as, the object didn't appear as big, and then when I moved closer and closer and closer looking through the hole, the object appeared to be more magnified. And so the images I could see were clearer at a farther distance because when I got too close, your eye can't bend and process all of the light images that are coming through the hole because it doesn't have as much space to do so. And so therefore, although the images when you're closer appear more magnified, they're not necessarily as clear. They are definitely more blurry. And so that leads me to the size of the hole that we poked through the foil here. The bigger hole has a clearer resolution because more light rays could come in, and I could see more of the image at a time. While when I had a small pinhole, just this tiny little pin, it was a much smaller portion of the image and it wasn't able to be seen as well. So then the final thing is the brightness or dimness of the object. And so we were able to see that when you had a smaller pinhole, if fewer light rays can pass through it to your eye, and therefore that made the object seem dimmer. So at a distance, the object seemed brighter, and as you got closer and closer and closer to the object, fewer light rays were able to pass through, and the object seemed dimmer, although in reality it hadn't changed. So that basically, we were able to illustrate how the light rays can be focused in order to alter the clarity, the brightness, and the size of an image when it's processed in your eye using something like a pinhole magnifier.